Why did we get into sketching derivative graphs? Like, what is the main purpose of that? And there's a couple which we're really going to try to hit on. But really, let's think about this for a moment here, which is the fact, okay, that if we take the derivative of, let's say, x to the 5th power, right, it's just 5x to the 4, right? We bring the 5 down and then subtract by 1. It's the power rule. Well, what if I want to take the derivative of sine of x? Or what if I want to take the derivative of cosine? Notice how these do not have, they don't have an exponent, right? We can't just subtract 1. There's nothing to subtract 1 from on the exponent. So we're a little bit out of luck. And since we don't have that option, what the next best thing to do is to sketch these and then try to make sense of them. So here they are. Y is equal to, this is going to be sine of x. And the graph down below is actually cosine of x. Okay, so let's try to understand any relationships. See if we can find any patterns, right? So I want to sketch the derivative of sine and see if I can figure out what it is. Well, first things first. When is it 0? Well, we know it's 0 at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Okay, well, from the left, are you positive or negative slope? Well, you are looks like positive slope, so you're increasing, so you know it's going to be increasing and heading down to 0. So let me just redo that one more time. Okay, it's going to be increasing down to 0, and then over here, this is decreasing, right? I drew that kind of bad, but this has negative slope. It's decreasing. Then over here it's increasing. Then over here it's decreasing. And then over here it's increasing. So notice how we're just alternating. It goes from increasing to decreasing to increasing to decreasing. All right. So let me just get rid of a few of these lines here. So we kind of got that positive, negative, etc., etc. So it went positive, negative, and has to come back. Well, I drew that kind of poorly. Come back, and it's going to alternate like such, and I'll probably just keep doing that. Okay, I didn't draw the best graph here, but you can kind of see it makes sense, right? Well, here it has positive, that's why we had positive derivative, and then down to 0, and then it's decreasing, so it's decreasing, but it has to get back to 0 again, so decreasing and then back to 0. Okay. Well, let me ask you a question. What do you notice about the derivative graph that we just drew? Well, if you look here very carefully, this graph right here is identical to this graph right there. Look at them, right? It starts up here. Well, it just starts up here. And then it goes down, and you can just see it. I drew it poorly, but they look identical to each other. They're the exact same thing, so it turns out the derivative of sine is actually cosine. And this is why it's so advantageous to be able to draw these, because we wouldn't have any other way of being able to do this with the tools that we have in this class right now. We just wouldn't. But being able to sketch these, we can then find out what it is. All right, well, let's go to cosine. Let's take the derivative of that. Well, we already talked about at these bumps it's 0. So I'm going to put 0. At pi it's 0, at 2 pi it's 0, right? I'm just putting these right here. At 3 pi it's 0. And at 4 pi it's 0. Alright, there it is. Okay, well, I know it's hard to see, but to the left over here, is this positive or negative? This is positive, so we know it's positive slope. So since this is the derivative graph and derivative is instant slope, it should have positive instant slope values. And then over here it's going to be, well, this is negative, and notice how it's going to go from 0, negative, back to 0. So 0, negative, but then back to 0. And now over here it's increasing, but goes from 0 to 0, but in between it's increasing. It's positive y value, so positive, and you can just see that it's going to alternate something like such. All right, well, my friends, does this graph look familiar? Now you can pause this video and you can graph these on your own paper and see if you notice any connection, and I'll go ahead and tell you. Okay, it turns out, my friends, that the derivative of cosine is actually negative sine of x. Well, let's think about that. Negative sine of x, that's a reflection. Well, notice how this right here, if we draw a reflection, it's going to be over here, and it's going to look, something like this and this, and it's going to reflect. Since it's reflecting, it's just going to reflect over, and you're going to get this green line. Well, does this green line look identical to the blue line? Yeah, it does, my friends. Look at how it starts, and right over here it has the bump, right there it has the bump, right here it has the bump. Notice it's just sine, but it's just been reflected over the x-axis. Okay, so that's our two big observations today. Is that now we know if I ask you to take the derivative of sine, well, that's just going to be cosine. And if I ask you to take the derivative, we'll just say let's say y is equal to cosine, and I ask you to take the derivative y prime, well, that's negative sine of x. It's just different ways of writing it, but you get the idea. So let's go and solve these problems to the left here. We're not going to plug the numbers in, but we can at least be able to do them. Let's take the derivative, bring the 4 down, and we get 4x to the, we'll subtract 1, it's third. Sine doesn't have any exponents, but who cares? We know what the derivative of sine is. That's just cosine, so we get plus cosine of x. What's the derivative of e? Well, e is just a number, right? And derivative of any number is 0, so that's gone. So there it is. That's our derivative. All right, let's go take the derivative of the second function here, but how about I go ahead and write it down over here. So let's rewrite this as f of x, 2 times x to the 1/2. I'm just going to rewrite it as a fractional exponent plus cosine of x. And let's actually get rid of this for now. We don't need to worry about that. Okay. All right. So how do we do this? Well, let's take the derivative of this function. Okay. Bring the 1/2 down. 2 times 1/2 is 1 times x to the, now subtract 1, but we're going to do it in a fancy way, 2 over 2. We get negative 1/2. Okay. Plus cosine of x. Okay, let's just continue. F prime of x is equal to, remember, a negative exponent means that you're going to put it on the denominator, so it's 1 divided by, well, x to the 1/2. What's the derivative of cosine? Well, that's negative sine of x. And there it is, my friends. That is the derivative of this function right there. All right, let's go ahead and do this last problem here, and hopefully you're kind of making sense of these. All right, take the derivative of that. We're going to get f of x, f prime of x. Well, negative 3 times 3 is negative 9x to the, subtract 1, negative 4. Bring the 2 down. 2 times 1/4. Well, think about the 2 multiplying with the 1. 2 over 4, so that's just 1/2. X to the 1. Or you don't even need to write the 1. Derivative of 2000 is 0, gone, doesn't have any, it's just a constant. Derivative of sine, well, that's just cosine. And we have the derivative of negative cosine, so let me write it over here. Well, what's the derivative of cosine? It's negative sine. And what's going to happen to these two negatives? Well, they're going to turn positive, so we get plus sine of x. I would finally rewrite this as negative 9 over x to the 4th. Right, just rewriting and putting it back on the denominator, 1/2 x plus cosine of x plus sine of x. And there is our derivative function for those 3 problems, all right? So that's just getting you an introduction with the derivatives of sine and cosine and how we were able to get them just sketching derivatives and sketching their graphs and not even having to do anything algebraically, all right? So I hope you enjoyed this video. I will see you on our next installment of what we'll